Hi all. See this, in this particular problem, we are actually asked to find out that these matrices cannot be A square, right? That's the problem. So suppose we are giving you a 3 cross 3 matrix which is A square, okay? Sorry, which is A. Now it says that A into A will be A square, right? And that cannot be equal to for these matrices, right? So that's the problem. So you have to identify that which matrix cannot be, okay, cannot be the square of this any real matrix, okay. Let's see that. So here we have to understand a basic concept here. So let's go ahead. So let A be any matrix of order n. So we just consider a square matrix, okay, n cross n. So therefore we can say that A square is equal to A into A, or we can say that determinant of A square is equal to determinant of A whole square. So that imply that determinant of A square must be greater than equal to 0. That's the condition. So we have to find that. So if we able to calculate each of the matrix and determinant, right? So determinant of A square must be greater than 0 to be a square matrix, right? So therefore we just write down the condition that so to become a matrix A square, determinant of A square must be greater than equal to 0, okay. So we'll start the calculation, okay. Now we don't start the calculation directly, okay. So first we observe the matrix D, right? Now for the matrix D, right, it's actually a diagonal matrix or a diagonal as well as an identity matrix. So if I consider that matrix as B, right, so we can say that consider the diagonal matrix option D 1 0 1 0 0 0 1 0 and 0 0 1. So this is an identity matrix. So determinant of B will be equal to definitely 1. That's okay. Now, look carefully now as option A, okay. So if I consider now the option A, right, we can see that to how we get that option A, right. If I multiply the second row, or if we multiply, or maybe if I take -1 common from that determinant of that matrix, we'll get the identity. So therefore we can say that determinant will be equal to 1 0 0 0 1 0 and 0 0 minus 1, okay. It's equal to -1 multiplied by determinant of B. That gives you actually -1, okay. So that's the determinant. Go ahead and go for that option B. Now option B, the determinant is say that it is 1 0 0, then 0 -1 0 and 0 0 minus 1. Now that will be, you see that we are having 2 -1. So you have to take -1 common into the determinant. That gives you 1 again. And if I take that option C, you will say that it is all diagonal elements are -1. 0 -1 0 0 0 -1. That gives you as -1 whole cube into determinant of B. That's why I'll give -1. Okay. Now see that. Therefore option A and option C cannot be the square of the real entries, right? Because in that cases, right, we are getting the determinant at -1. So therefore for this problem, option A and option C is the right option. So that means we cannot have a matrix A such that A square will become this two, okay, because of the determinant, and that's it. So it's a very simple problem. It just understand our observation power. That's it. Hope you understood the problem. Thank you.